Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn how to solve algebra word problems. Today we'll do problem number 111. Problem, as you can see, is already on the blackboard. Let's take a look at it. We are told that the digits of a two-digit integers are reversed. So we have a two-digit integer. We don't know what that two-digit integer is. Say for example, if it's 37, our job is to reverse the digits. 73. 37 becomes 73. Reverse the digit. And we are told, as a result, the new number that is obtained differs the original by 18. As you can see, 37 does not differ 73 by 18. 37 does not differ. It differs by 36. It says, as a result, the new number differs the original number by 18. The question is, how much do the digits differ? It's very important that we understand the question. How much do the digits differ? They're not asking us what that integer is. They're not asking us what is that integer, what is that quantity. They're simply asking us how much do the digits differ. For example, if we were dealing with 37, the digits differ by 4. Whether it is 37 or 73, the difference between two digits is 4, and that's what they're looking for. How much do the digits differ? So it's important that we understand the question. The second thing that you have to know here, the second thing that we need to understand here is the concept or the notion, the idea of being able to write a two-digit integer in the language of algebra. If you have not watched problem number 65 and 91, pause this video immediately, stop this video that you're watching right now. You search for number 65 and number 91 under algebra word problems. Just type in algebra word problem number 65 and the video will pop right up, and 91, and watch those videos first. That's where we learn how to express the notion of a two-digit integer. For example, let's take a look at this 37 here. For example, if it's 37 and if we say that x equals 3 and y equals 7, how do we express 37? We cannot simply say xy. That's not 37. xy is not 37. In the language of algebra, xy is simply x times y, which is 3 times 7, which is going to be 21. It's not 37. We want to represent 37 here. And how do we do that? Well, keep in mind that our x is equal to 3 and y is equal to 7. And watch what happens, okay? What does this 3 represent? This 3 is the 10 digit. This 3 is the 10 digit. It tells us how many tens there are. 37 is so called because it has 3 tens and 7 ones. That's why it's called the unit digit. It's called the unit digit, and this is called the tens digit. And the unit digit. It's called unit digit because that tells us how many units we have. We have 7 ones and 3 tens. If x is equal to 3, then if you want to express 37, then this is how we do it. If x happens to be 3, then we replace here with x times 10 plus y times 1. X times 10, we don't write it out like this in the language of algebra. We write x times 10 as 10x, and then y times 1 is just y. There you go. This is your 37. This is your 37 if x happens to be 3 and y happens to be 7. This is how we express a two-digit number. Whatever the unit digit is and whatever the 10 digit is, 10 digit has to be multiplied by 10. That's how many tens there are. 10 times x plus y. Technically it is y times 1, which is just y. So let's do that then. Let's do that here. Now that we understand it, let's start the process. So we're going to make up our two-digit integer. We're going to make up our two-digit integer. 10 times t for the 10 digit, plus the u. That's our two-digit integer. And what happens when we reverse the digits? When we reverse the digit, then instead of 10 times t, it is going to be 10 times u. And 10 digit, whatever it is, becomes the unit digit. And we are told that the difference between the two quantities, they differ. As a result, the new number obtained differs the original number by 18. There you go. Now we do our work here. Open the parentheses, we get 10t plus u minus 10u minus t equals 18. We get 10t here minus a t, that's a 9t, and then we have a u and minus 10u. U and a 10u is going to give us minus 9u equals 18. I'm going to rewrite this thing because I just made it too messy. I don't like it. Let's rewrite it so that it doesn't look so messy. 10t plus a u minus 10u. Don't forget this minus is outside, so this positive is going to become negative. There we go. And then this 10t and this negative t, and then this u and this negative 10u. So 9t minus 9u equals 18. If you divide the entire equation by 9, we get t minus u equals 2. And there is your answer. Because the question was, by how much do the digits differ? The digits differ by 2. The digits differ by 2. So what is that integer? What is the integer? The answer is, we do not know. We do not know what that exact integer is. All we know is that the two digits differ by 2. There are several possible scenarios. Let's look at all the possible scenarios, shall we? Because the question is not asking us what is that two-digit integer. The question is not asking us what is that two-digit integer. If the question were asking us what is that two-digit integer, the answer is there is no way to figure it out because we only have one equation and two unknown. They are not looking for the individual values of the 10 digit and the unit digit. They are simply looking for the difference between the two. Let's look at the possible scenario here. I'm not going to erase this part here so that you can have there. Make sure you watch 65 and 91 if you have not done so. So the difference is 2. So let's begin. If the difference is 2, let's start with something simple. Let's start with 1. So we can have 31 and 13. I'm putting 31 on the top because it's easier to see that the difference is 18. Or we can have 42 and 24. That's the difference of 2. 4 and 2, difference is 2. And you will see that 12 minus 4 is 8, and 3 minus 1 is 18. You see the difference is 18. When we reverse the digits, the difference is 18. Or we can have 52 and 23. Again, the difference is going to be, did I make a big, that's a difference of 3. I made a mistake here. I wasn't paying attention here. 23 is fine. 23 is also not fine. I'm not paying attention here. So we can have 53, see 5 and a 3, the difference is 2, and 35. The difference again is going to be 18. Or we can have 6 and a 4, and a 4 and a 6. Or we can have 7 and a 5, and a 5 and a 7. Or we can have, so that's so far 1, 2, 3, 4, 5 scenarios. There are 7 different scenarios. So we are up to 7. Let's go to 8. So we can have 86 or 68 or 97 and 7. 2, 4. Did I miss one? We have 1, 2, 3, 4, 5, 6, 7. Oh, I missed 8. I have 7 and 9. Now we have to do 8. Let's do here 8. So we can have 81 and 18. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4. What the hell? We have 13, 24, 35, 46, 57, 68, 79. That's a nonsense. I don't know what I was thinking. That's a nonsense. That's a difference of 7. That's it. Those are the possible scenarios here. But anyway, we don't have to waste our time doing this out. Nobody was asking us to enumerate all the possible scenario. They were simply looking for the difference of the two digits, and the answer is the difference of the two digits is 2. The difference in the two digits is going to be 2 if you're dealing with the situations where if you were to reverse the digits of a two-digit number, then the difference has to be 18. If the difference has to be 18, then the digits have to differ by 2. Bye now.